Okay, thanks, Roque, for that kind introduction, and delighted to be speaking to you all. And yes, it really is an international meeting or event we have here. So I'm obviously speaking to you from London in the UK. We have Roque in Abu Dhabi in the United Arab Emirates, and we have all of you guys over in the Philippines. So we're covering quite a few time differences there, aren't we? I think. And so it's 7 a.m. in London at the moment, and it's probably early afternoon in the Philippines, maybe. So yeah, hopefully that's all coming through there. So yeah, really happy to come along today and to give you this presentation to help provide an introduction to the wider kind of engineering management context. I know that you're considering the Associate Engineering Manager training as well. So I do have a little bit of information about the American Society for Engineering Management. And so today what I'd like to give you is just, perspectives on engineering management, managing technologies and project teams in a complex world. And what I'd like to do is talk a little bit at the beginning about how we could think of engineering management like a toolbox that could provide us with tools, techniques, and knowledge to help us navigate kind of knowledge-based technological areas. And in order to illustrate how useful it could be, I'm going to talk about three particular areas as like almost little case studies or examples of how engineering management can be used. And I will be looking at some research highlights of mine from project management, from some work on clean technology studies, and also looking at sustainable engineering. And then I do have a little bit of information on the American Society for Engineering Management, of which I currently serve as the past president. The previous year, I was the president of the society. You serve as a president for 1 year, and then you serve for 1 year as the past president. Okay. But before we go into that, I thought it'd be useful to give you a little bit of a flavor of my own background. So I currently work at a university called London South Bank University in the United Kingdom, and I serve as a professor and the director of the Natu Puri Institute for Engineering and Enterprise, which is a little bit of a mouthful to say. And I carry out engineering management, research and education, looking at innovation, entrepreneurship, project management, those kind of areas. Those are my academic areas. But before I took my job at London South Bank, I worked at a different university called Imperial College London for 15 years, and I held a number of manager and director level positions there. I started out my career in the Ministry of Defence, and was actually working in chemistry. And I suppose that brings me to those pictures there. And so, there's a picture of a laboratory at the bottom there. And I mean, that's not the laboratory that I worked in, but I worked in a lab similar to that. I did a PhD in organic chemistry. And those are a couple of compounds that I prepared in my PhD. And if I can remember the names of them, so the single cyclic compound, that's 2,5-diamino-3,6 dinitropyrazine, and let me see, the bicyclic one is 2,4-diamino-6,8 dinitroquinazolene 1,4 dioxide. So yeah, it just rolls off the tongue, as we may say. So I started out in the physical sciences and organic chemistry, but I really moved into management in my career. I've done a lot of project management and program management at different levels, managing projects, at maybe £100,000 or £200,000 or dollars level, up to 1 million, 10 million, and I've been involved in initiatives at the kind of $200 million initiative kind of program level. So different kind of financial scales of projects and programs, and I've also worked with different sectors. So originally come from the defense sector, defense and aerospace, but I've worked with partners and on programs with the nuclear power sector, with the pharmaceutical and healthcare. I've done a lot of work with the oil and gas industry, major oil and gas companies, worked with over the years like Shell and BP and others. More recently, quite a lot of work with the built environment sector, the construction industry. And many years ago, I was involved with a collaboration with the company that made the SRBs, the solid rocket boosters of the shuttle. And there's a picture there. So I went over to their facility in Utah, and that was a really nice initiative to be involved with. I suppose the thread that links all these quite different industries is they're all knowledge-based industries, all knowledge-based sectors, where to be successful in those industries, you need to have access to the latest science and technology to be competitive as a company, or to provide a leading capability for government funded initiatives. So that's really a quick run through my career. Started out as a physical scientist and moved into engineering management and senior management roles. So I said at the beginning, excuse me, sorry about that. It is still early in the morning in London. So I said at the beginning that we could think about how we could view engineering management maybe as a toolbox. And so I have a quote there from the American Society for Engineering Management, and it says in italics, it says, the subject of engineering management is concerned with the management of people and projects in a technological or engineering systems context. And it also says the successful engineering manager will have the ability to manage complex programs and systems while drawing on the tools and techniques developed within the field of engineering management. And so my question is, can we use engineering management as a toolbox to investigate how we develop and manage research, technology, and engineering systems? And I should add to that, how we can manage technical projects as well. And so I'll go through these three areas to illustrate how I've carried out research in this area and been involved in delivery of projects as well. So the first area I'm going to talk about is some research highlights from project management. Now, I'm sure many of you have come across project management before, and so I have some introductory comments. Now, the interesting thing about projects are everywhere, aren't they? Mm-hmm. And there's some research carried out here by a group called the Standish Group, and they looked at IT project management. Now, interestingly, they found, now it's a little bit old, this reference 2009, but I think they've undertaken a number of reports, and they tend to be a similar story that they find. They find that over and over again, many IT projects continue to fail. And they find, they do this annual survey. They find that if we look at a large number of IT projects, usually only about a third of them are successful. About a quarter can be considered as complete failures. And 44% odd can be considered as challenged, where they may have finished late, or they may not have met all the requirements of the users. So time and time again, we see a lot of challenges in IT project management. Now, we have had the development of the movement called Agile. Agile project management has gone a long way to tackle the problems of the so-called waterfall project management. But nevertheless, IT project management is still very challenging, and often IT projects can be can encounter failures. It's also interesting to think about some other kind of large-scale projects. Now, hopefully you can all recognize this famous building. And of course, this is the Sydney Opera House in Australia. Now, the interesting thing about this building is that it was actually completed 10 years late. Now, that is a serious overrun of the project schedule, isn't it? The time frame of a project. And the project cost, back in the 1970s, apparently it cost 100 million Australian dollars. And that was back when 100 million was quite a lot. But it was meant to have cost $7 million. That's 15 times over budget. Now, back then, we may have looked at that building and that project, and we might have thought to ourselves, well, this is a failure. This project is overrun massively. There were big issues with fallouts between the architect and the designers, and the project encountered a lot of difficulties. But if we look at the building now and the project that gave rise to that building, we would think, well, it was a fantastic success. It acts as a great, attraction point to for people to visit Australia. It's a very iconic building. Whoops, a little bit of interference there. So yeah, but we could think of it as a great success. So it's interesting, over time, our perspective over what a successful project is can change. Another example, a large kind of scale project. This was a project to develop a new airport terminal for the Heathrow Airport, which I think is one of the busiest airports in the world, or certainly within Europe. And so this is a large terminal. It cost £4.2 billion, and it was completed on schedule. So that sounds good. And it was completed within budget. So, okay, the project was proceeding well back in 2008. Now, the issue is when the facility was opened, it was plagued by problems connected with the baggage handling system. And in the early days, there were cases of thousands of bags just piling up in the terminal, people going on holiday and on their trips and their bags not going with them. Apparently, there were stories of people turning up to the building to work and getting lost in the building because it was so large and they didn't know where to report to. So there were some issues in terms of the startup or the opening of the facility. People at the time thought, well, this project has not worked very well at all, even though it had actually been delivered from a construction perspective on time and within budget. And we could see that potentially smaller issues around the baggage handling, lack of training, lack of communication, systemically contributed jointly and had this impact on the opening of the facility and the project. So we can think about projects from a systems perspective, a broader perspective. Now, looking back on the project now, most people, I guess, have forgot about the issues with the baggage handlers, and people would think that it was a successful facility in an airport. But again, it points to kind of the complexities of projects. In project management, we often think about the traditional iron triangle, it's called. And so we think about delivery of projects according to a schedule, which is the time, within a scope of resources, the cost and the budget, and according to a set of functionalities or the technical scope. And all these, the parts of the triangle, it's to deliver the project to a given quality level. So the iron triangle, is still important, but as I've tried to indicate, engineering projects can be subject to complexity and challenges, whether they're IT or construction or other types of technology and engineering projects. The iron triangle is still important, but can we adopt this broader viewpoint from this kind of systems perspective, or utilize the techniques of systems engineering to manage that complexity? So I conducted a a study of 25 industrial companies a number of years ago in order to explore these kind of issues. And these were companies from across the United Kingdom. And we found that technology and engineering projects can encounter a range of different challenges and issues. They found that actually, I found that there are a range of different tools and techniques available, but there needs to be more clarity on which tools to use at which stage of the project. I also found that there's a need to link the technical part of projects to the enterprise or the commercial side of organizations, to have a stronger linkage, and also a greater need to manage the complexities around uncertainty, not knowing what is happening within a project. And so this study was written up and published in an American journal called Research and Technology Management. And it provides a framework that you can use for managing highly engineering, highly complex technical projects. We could go through a number of frames. You start with the integrated systems design, which is where we capture the requirements of the engineering system. You then develop the systems architecture, and you may have to go back to frame 1 to do further requirements as you go forward, but nevertheless, you start from frame 1 and go to frame 2, then on to frame 3, where you do systems integration between the different systems that you're considering. And then ultimately you move on to frame 4, which is the system of systems management. And there are techniques that you can use. All the time you're drawing on underpinning knowledge from systems theory, and you're linking your technical project to the enterprise level. So that was where I carried out some research to try and develop an improved understanding about how you manage these uncertain and complex engineering projects. And then a few years later, I was involved with overseeing the development of an interesting piece of equipment where I was able to apply some of this knowledge and these techniques. And I was working with a team of physicists, and we were developing a new high pressure facility, which was going to be installed in it's Imperial College London. And I was working with a team of engineers, and this piece of equipment is about 20 meters long. It's 2 meters high, it weighs several tons, and it had to be designed and manufactured in America and transported over to the United Kingdom. It was a very demanding engineering specification. There were a lot of risks associated with the manufacture and design of this specialist piece of equipment. We had to do a lot of finite element analysis, modeling of the structures to make sure that they could accommodate the stresses that would be involved with operating a high piece of high pressure piece of equipment. So I applied some of my techniques from engineering management so that we could deliver this complex piece of equipment. And so the diagram at the top there summarizes the kind of approaches that we used to support the design and the overall safety engineering that we achieved. So we used a lot of system design visualization, a lot of architecture management to capture the complexity. We managed the risks, the engineering risks, using something called FMEA, failure modes and effects analysis, which is a systematic way of capturing engineering risk. We also made sure that we were drawing on people from different functional areas. So we were linking, mechanical engineers with electrical. We had management and we had physicists, and we had safety, commercial, lots of different functional areas. And we did other approaches as well. And so drawing on these kind of different techniques, we were able to manage the complexity of delivering this, high pressure piece of equipment. And I was able to write up this in the journal, Engineering Management Journal, the EMJ, which is the journal of the American Society for Engineering.